In 2019 and 2020, we conducted an experiment to evaluate the response of soybean yield and grain quality to sulfur and nitrogen timing of application in a corn soy rotation. Funding for this research came from the Pennsylvania Soybean Board. At corn planting in 2019, we applied sulfur at a rate of 40 pounds per acre using ammonium sulfate, elemental sulfur, gypsum, and poultry litter as the sulfur source. We used the same plot area in 2020 rotated to soybeans in order to observe the effects of the previous year's sulfur application. Additionally, we split the control plots in 2020 so each replication had a plot which receives sulfur as ammonium sulfate or gypsum, nitrogen as urea, and an unamended control. In fall of 2019, spring 2020, and fall of 2020, we collected soil samples to 32 inches in order to determine the distribution of sulfur in the soil profile. At all three sampling dates, we found that there were no significant differences between treatments at the 0 to 8 inch or 8 to 16 inch depths. However, at the 16 to 24 inch and 24 to 32 inch depths, treatments which received sulfur generally had higher sulfur content even after 2 years of crop production. During the 2020 soybean season, we collected plant tissue samples when the plants were at the V2 and R1 growth stages, as well as soil samples to monitor plant rooting depth. At the V2 sampling, the soybean plants had roots extending to 13 inches, which was above the soil depth at which we observed increased sulfur. The 2020 gypsum and ammonium sulfate treatments had greater sulfur content than the control, and the 2020 gypsum treatment had greater sulfur content than all of the treatments which received sulfur in 2019 except for elemental sulfur. At the time of sampling at the R1 stage, the plants had roots extending to 28 inches, well within the portion of the soil profile at which we observed large amounts of sulfur. We found that treatments which received sulfur in either year had greater sulfur content than those which did not. This suggests that by the time the soybean plants reached the reproductive phase in their development, their root systems were accessing sulfur in similar quantities, regardless of which year the sulfur was applied. Soybean grain was harvested in late October. We found that there were no significant effects of sulfur source or year of application on grain yield. Due to the severe drought which occurred at the site during the summer and fall of 2020, it's difficult to draw conclusions about yield. During harvest, we collected grain samples which were analyzed for sulfur, methionine, and cysteine. The 2019 elemental sulfur, 2019 poultry litter, and 2020 gypsum and 2020 ammonium sulfate treatments resulted in greater sulfur concentration than the control or 2020 urea treatment. The 2019 gypsum and 2019 ammonium sulfate treatments were not significantly different from the control in terms of sulfur concentration. For methionine concentration, we grouped the treatments by those which had received sulfur in either year and those which did not. We found that the treatments which had received sulfur had greater methionine concentration. We used the same group of treatments and found that the treatments which had received sulfur also had greater cysteine concentration. Our results indicated that there was not an effect of sulfur fertilization on grain yield. However, grain sulfur concentration increased as well as the concentration of the sulfur-containing amino acids cysteine and methionine. This suggests that in cases where sulfur doesn't limit yield, there are still some effects of the addition of sulfur. We also found that even after 2 seasons of crop production, subsoil sulfur content was higher in treatments which had received sulfur in 2019 than treatments which received no sulfur in either year. This illustrates the fact that the subsoil can act as a reservoir to hold sulfur for use by multiple crops. Our soybean plant tissue testing data indicated that once roots reached deeper soil layers containing sulfur, plants readily took it up. Finally, when considering the potential interaction between nitrogen and sulfur, our plant tissue, soil testing, and grain analyses all indicated that gypsum and ammonium sulfate performed equally well. It also appears that if sulfur is added during the corn year of the rotation, producers should be able to rely on excess sulfur stored in the clay subsoil.